Okay, so we're going to pick up where we left off on our notes 79. This last example, I'm actually going to show you a couple of ways that we could solve for the particular solution. We're going to go ahead and do what the paper says first, and then I'm going to show you something else. Just in case you get stuck on one and you do need just a particular solution, then it would work. So for now, it asks us to find the general solution. So when you see that, that means that they do want you to solve for y. They want the dependent variable in terms of the independent variable. So solve for y. So we still need to separate our variables. So we're going to multiply this by dx, get rid of our dx, and then we're going to divide both sides by y minus 2. So we have the integral of 1 over y minus 2 dy equals the integral of sine x dx. All right, so this one is going to be a natural log, so ln of y minus 2, and the integral of sine is negative cosine of x plus c. Now, if it didn't ask us to go ahead and solve for y, we have a general solution. It's just not with y by itself. So we need to finish this thing out. So we're going to do what we did in the problem above. If you remember up here, when we got to this point, we put e to this power equals y. So that's what I'm going to do here. We're going to have e, understood, base e, to the negative cosine x plus c power equals y minus 2. And we know that, like we did in the problem above, addition becomes multiplication. So e to the negative cosine x times e to the c power equals y minus 2. All right, when we see this e to the c power, that is just an unknown. It's just a constant again of some kind. So we can just replace this with a c, some unknown constant, times e cosine, negative cosine x equals y minus 2. And then I'm going to solve that for y. So I have y equals, let's see if I add the 2 over there, c e to the negative cosine x plus 2 power, or plus 2. All right, so this would be my general solution. And by general solution, it means that we didn't solve for c. We don't know what c is yet, but this equation would work for whatever value of c. Okay, so in the next part, they want us to use our equation to find the particular solution if x is pi halves and y is 8. So 8 equals c e to the negative cosine of pi halves power plus 2. Well, cosine of pi halves is 0. So this is e to the 0 power. E to the 0 power is just 1. So this is just c. So c is going to equal 8 minus 2, or 6. So the particular solution would be y equals 6 e to the negative cosine x power plus 2. All right. So what I'd like to do is go back and talk just a minute about when we rearrange this right here. If we had taken this form before we rearranged, and we just, in this form, went ahead and plugged in our particular solution. Now, this only works if you need the particular solution. So I went ahead and put in right here, ln of 8 minus 2 equals negative cosine of pi halves plus c. Well, this would be ln of 6 equals, and then cosine of pi halves was 0, so ln of 6 equals c. And then we could rearrange e to the c equals 6, and we know that this is just a constant of 6. And so we'd have our 6 there on the end. So you could do that and still get the same answer, but don't forget that you would still have to go back and rearrange it, and then this separation would become multiplication. So I'm not sure that that's any easier, but I'm just throwing it out there as a possibility. But I would just practice finding the general solution prior to plugging in to find the particular solution. So go ahead and solve for y is what I'm saying. On these problems that involve the logarithms, go ahead and solve for y, and then plug in your specific solution. All right, so at the end, they say, notice the pattern here on our last couple of examples. This number here in front, our C value, it's just, it always ends up being a part of our point that was given. So here's what I'm saying. In this one, our point given was 10. This ended up being 10. In this one, our y value was 8, but remember that we had 8 minus 2 in our equation, so this was 6. So there is a little pattern to that if you want to use that. All right, so on your paper, there are going to be some other examples. So I want to go over one more thing before I leave you to it. If you have a problem like this, don't forget that this is also something that you could separate out, like subtraction is division, just like addition is multiplication. So e to the v minus u power b e to the v over e to the u. And that way you can separate it out. So look for the algebraic things that are going to help you separate your variables. And then this one becomes pretty easy. Multiply by dv. And so multiply by e to the u. We get e to the u du equals e to the v dv. And then we can integrate. And don't forget the integral of e to the u is e to the u. So this would just be e to the u. This would be e to the v plus c. All right. If you run into any problems while you're working these out, don't hesitate to send me a message or a picture, or if you need to give me a call, that's okay too. We're just going to have to wing it as best we can since we're at the end of the semester in our last unit and we're not in school. So please don't give up. Please keep trying. And if you have any questions, then please let me know.